In this class, I will discuss some more problems on coplanar, concurrent, non-concurrent force system, finding the resultant force. This is also a VTU model question type of problem. Here he has given 1, 2, 3, 4 forces and an external couple or a moment on a rectangular lamina of dimensions 4 meters and 3 meters. 18 Newton force acting at D in the, of course, the fourth quadrant at an angle 45 degree. 60 Newton force acting at C in the first quadrant making an angle 30 degrees. 100 Newton force acting vertically downwards at B. 100 Newton force acting at A towards right, and an external couple of clockwise nature 150 Newton meter acting anyway. So the effect of this couple or moment remains same whether it is given here or here or here or here. So we have to take only the magnitude of the pulsar. Now he has asked what is the magnitude, direction and the position of the resultant. So R, alpha, D. So let us calculate the position with respect to this point A. So if we are calculating the position with respect to point A, we need to calculate sigma MA, and then we have to find the value of D by this D is equal to modulus sigma MA by R. So this is the method. Now first step is to find the algebraic sum of the forces along x and y directions, treating towards right positive and upward forces positive. So for that we have to resolve the forces into x and directions. So let me take x direction like this, y direction like this. So let us resolve the forces now. This 80 Newton force if resolved, so horizontal component will be like this, vertical component will be like this. So since this 45 degrees is with respect to x-axis or horizontal, so this component becomes 80 cos 45 and this component becomes 80 sin 45. And coming to this, start from the plane into vertical, horizontal component is this, vertical component is this, 60 cos 30 and 60 sin 30. And these two forces you need not resolve because they are acting vertically and horizontally, so we need not resolve them. Now sigma fx by treating forces acting towards right positive, this 8 cos 45 is positive, this 6 cos 30 is positive, 100 Newton is also positive. So when you are writing sigma fx, sigma fy, this extra couple of moments should not be considered. So 80 cos 45 plus 60 cos 30, 60 cos 30 plus 100. So this is the value of sigma fx. Sigma fy, vertical components downward negative, upward positive, minus 80 sin 45, minus 80 sin 45, then this is plus 60 sin 30, 60 sin 30, and this is minus 100. So this doesn't have a vertical component. So these two are the values of sigma fx and sigma fy. Let us calculate that. 80 cos 45, so 80 into cos 45 plus 60 cos 30 plus 60 into cos 30 plus 100, it is equal to 208.53. So 208.53 newtons. So unit is Newton. 205.83, 208.53. 208.53 Newton. Since it is positive, it is towards right. Then sigma fy minus 80 sin 45 minus 80 into sin 45 plus 60 sin 30 is 45 because sin 30 is half. 60 sin 30 is 30. It is sin 30. So then you have minus 100. So the value now it is minus 126.57, minus 126.57 Newton. So negative means it is acting downwards. So once you know the directions of sigma fx and sigma fy, you can fix the quadrant of R. So here you can see sigma fx is positive like this, sigma fy is negative like like this. So therefore R lies in the fourth quadrant. So and the angle made by R with x-axis is alpha. Now you can find out the magnitude or sigma fx square plus sigma fy square under root, which is 208.53 square plus minus 126.57 square under root. So if you simplify that, so you will be getting 208.53 square. The answer here we are getting 243.94. So this is the newtons. This is the magnitude of R, resultant. Magnitude of resultant. Now the direction, you know that this lies in the fourth quadrant by knowing that for sigma fx, sigma fy. Direction of R, which is given by alpha, direction of R is equal to alpha tan inverse of modulus sigma fy by sigma fx, which is tan inverse of modulus minus 126.57 divided by 208.53. Anyway, we take the positive value because of modulus. So you are going to get this value. So 1 tan inverse of, I am right, tan inverse of 126.57 divided by 208.53, which is 31.26 degrees. 31.26 degrees. So this alpha value is 31.26 degrees. Now, once you get this, so this is direction. Now we consider we will calculate the position. Position of R resultant with respect to any point. So here we have not given any point. We can choose ourselves the point. I will take with respect to point A. So I will find out the location with respect to point A. So the unit sigma union. Sigma union reading clockwise moments positive, anti-clockwise moment negative. Now at A we have 100 Newton force that doesn't have any moment because the line of action passes through A, perpendicular distance is 0. Due to this force also it is 0 because 80 sin 45, if we expect the line of action, it passes through A, there is no perpendicular distance. But this force 80 cos 45 gives a clockwise moment about A. So the value is clockwise, therefore plus 80 cos 45 into distance, this is vertical distance to the line of action, which is 3 meters. So plus 80 cos 45 into 3. So that is the moment due to this. Then coming to this force 60 cos 30 is the force. It is also giving a clockwise moment about here. See the arrow here. To come to here we have to move clockwise direction. So plus 60 cos 30 into once again distance is 3 meters. Plus 60 cos 30 into 3 meters. Then this force 60 sin 30 also gives a moment, but it is anti-clockwise in nature about the point A. So minus 60 sin 30 into distance is 4 meters. So minus 60 sin 30 into distance is 4 meters, horizontal distance. Then come to this 100 Newton force. This is giving clockwise moment about A. So plus 100 into 4. Plus 100 into 4. And of course this 400 Newton is not giving any moment about A because there is no perpendicular distance. And this 150 Newton meter clockwise couple is also given. So just add 150 plus 150 because it is clockwise. If it is anti-clockwise, minus 150 we have to take that. So the effect of this remains same wherever it acts. That's why I have not given any distance from the point A. Wherever it acts, just you have to add 150. That's all. Now we will simplify this. This is the algebraic sum of the moments of all the forces about the point A. Because we are finding the position of the resultant with respect to point A, we are calculating sigma in A. So 80 cos 45 into 3 means 240. 80 is 240. 240 into cos 45. Then plus 60 into 3 is 180. 180 into cos 30 plus 180 into cos 30. then minus 60 sin 30 into 4. So that is minus sin 30 is half. So 30 into 4, 120 it becomes 120. Then plus 400, 100 into 4 plus 150. So this is the moment. 755.59. 755.59. So once again I will check. 80 into cos 45 into 3, 240. 240 into cos 45. Okay. Plus 60 cos 30 into 3. That means plus 180 into cos 30. Then minus 240 into 70 means 120. Minus 120. Then plus 400 plus 150 means 550. Plus 550. So 755.59. 755.59 Newton meter. So you are getting positive value. That means the net effect is clockwise moment. 755.59. That is the moment. Now once you get that, you can find out the distance now. So distance, perpendicular distance of the resultant from the point A, you are going to get D. D is the perpendicular distance of R, line of action of R, from point A. So this is given by sigma MA divided by R modulus. Because the distance I am taking positive value, modulus I will take 755.59. 755.59 divided by the magnitude of R is 243.94. So the value is here. You will be getting 243.94. The value is 3.097. 3.097. Please check the other values meters. That is the consumer distance. Now if you want the x-intercept and y-intercept, x-intercept is given by d by sin alpha. So d is 3.097 divided by sin alpha is 31.26 degrees. So 3.097 divided by sin 31.26 degree, which is 5.96, 5.968 or 5.97 meters. That is the x-intercept. Y-intercept d by cos alpha 3.097 divided by cos of 31.26 degrees. 3.097 divided by cos of 31.26 degrees, which is 3.623 meters. 3.623 meters. So these are the x and y intercepts. Now let us locate the resultant. That is also important. This is x-axis, y-axis. This is the point A, about which we have found out the position of the resultant. So this resultant is giving a clockwise moment about the point A. So clockwise moment, and also it is in the fourth quadrant. That means either it should be, so now the direction is fixed. So either it will be like this or like this. So there are two possibilities. This is R, this is R. Now among these two, the direction is fixed based on this. Among this, whichever is correct, we have to judge. So this is giving the clockwise. Sigma M is clockwise. Therefore, resultant force is giving a since the algebraic sum is clockwise, moment of the resultant also should be clockwise as per Wegener's theorem or principle of moments. Now among these two, which is giving clockwise moment about A, that is the answer. So this is giving clockwise, this is giving anti-clockwise like this. This is giving clockwise. Therefore, this is correct. This is not there. So now this is the, if you drop a perpendicular from A to this line of action, that is your D, to which value is 3.097, and of course this is alpha with respect to x-axis, and x is this distance. X is this distance, x-intercept, AM, and AM is the y-intercept, so that is y. So now this is how the x value is 5.97 meters, y value is 3.623 meters, and d value is 3.097 meters. This is how the resultant passes. So now among these two, so this is correct, therefore this is not. So you should judge the position or the location based on the nature of the moment about which you are taking the algebraic sum of the moments. So this is how we have to do the problem.